All right, so we're finally on to chapter 4. So let's talk about this. We've talked about triangles before. So obviously, what's like if somebody asks you about a triangle, tell me one thing you know about a triangle. Somebody tell me. Three sides. Okay, that's probably the most basic thing to know about a triangle. Would you agree? All right, the triangle has three sides. So that's one thing you know. Amaya, what were you going to say? Okay, there's things called isosceles triangles. Did we talk about an isosceles triangle? I don't think we did. I think we're going to talk about it in here. Yeah, in fact, today we're going to talk about it. So you're absolutely right. So you knew that from before. So a lot of the stuff that we're going to learn today, you probably already heard. You may not have delved like really deep into it, but you probably heard a lot of these words. Okay, some of the words you probably will not have heard before, but we're going to learn them today for the first time. Is there anything else about triangles that you know? Something else we're going to do that's kind of interesting. Okay, obtuse, that's good. That's an obtuse angle. You can have an obtuse triangle, right? So we're going to talk about that today. What else from your past that you may know about triangles? Okay, good. There's a triangle that's got a right angle in it. So what do you think we call that? A right triangle. Very good. Okay, so absolutely. The stuff that you're telling me, that's the stuff that we're learning today. All right, we're going to learn some other things. Let me test you a little bit. Did you ever learn if you added up the three angles inside of a triangle, what they add up to be? Say it real loud. 180, okay, 180. That's what we're going to learn today. But I'm going to show you why. I'm going to show you why it's 180, okay? Probably, my guess is, in the past, they didn't really teach you why. They probably just told you, see all three of these angles? They add up to 180. Boom, you're done. You move on, right? But I'm going to try to show you today why that's true, and I think it's kind of interesting. All right, enough of that. So what we are going to do, we know a triangle has three sides, all right? So that's pretty straightforward. And what I'm going to do is I'm going to draw a triangle for you. Of course, all these triangles have three sides. But we're going to talk about, let's do about, it seems like every time I draw one of these, it always looks like a right triangle. I don't know why. See, it looks like a right triangle. I don't know how to draw this without being a right triangle. Maybe because I always make this thing. Anyway, that's fine. So let's take a look at this triangle. It's not a right triangle. That is not a right angle. Might look like it, but it's not. Okay. When we talk about an angle, I think we've talked about this before. We have talked about obtuse angles before, haven't we? Yeah, I think early on, right, we talked about that. We talked about another angle that's less than 90 degrees. What do we call that? An angle that's less than 90 degrees. It's an acute angle. Very good. Right? So an acute angle is less than, I'll just write it out, less than what? 90 degrees. Okay? I don't like how I drew this triangle. Let me try to draw it. I don't know. It's so... Let's just push this in a little bit. Yeah, this probably looks a little bit better. There we go. That looks a little less than 90 degrees. Okay, so here's a triangle, all right? This angle right here is less than 90 degrees. This angle right here is less than 90. And this one right here is less than 90. So what are all three angles? What do we call them? Acute angles. So this is a triangle with three, what? Acute angles. And so what do you think we're going to call this type of triangle with three acute angles? It's pretty simple. Say it. An acute triangle. That's right. So we call this an acute triangle. And there's a symbol that we use for triangle, and it looks like this. It looks like a little triangle, okay? So that's our symbol. So instead of writing triangle every single time, we can write that little symbol, and that means triangle. Everybody okay with that? So that's an acute triangle. Does an acute triangle just have one acute angle? No. Does it just have two? No. How many does it have to have? All three of them. All three of them have to be acute. Everybody got it? So it's got to have three, exactly three acute angles. All right, let's do another one. You probably know what this one is as soon as I draw it. What is that? Do I know that's 90 degrees? Do I? How do you know? Is that square? Is that squared up? How do I know? Just because of what? Looks like it, doesn't it? All right. That's one thing we can't go by in geometry. All right. Sometimes it might guide us a little bit, but we can't put all our eggs in that basket just because it looks like it's 90 degrees. That could be 89.99999 degrees. Would you agree? It could be, right? And I wouldn't be able to tell the difference. Would you be able to tell the difference? No, I wouldn't be able to. All right. So I can't say it's 90 until what? Until they put something in there. What do they put in there? That little box. That's right. If they put that little box right there, then they're telling me what? That this angle is 90 degrees. Everybody with me on that? All right. So just looking at it and saying, it looks like it's 90. No, don't go by that. Make sure that they tell you that it's 90 degrees. All right. And that little box right there means it's 90 degrees. So this triangle has how many 90 degree angles? Just one. It has one, we'll call it a right angle. 90 degrees and right are the same thing. 90 degree angle, right angle, same thing. So it has one right angle. Doesn't have three right angles. In fact, could we even have a triangle that has three right angles? Could we have one that has two right angles? No. Watch. Let's do this. There's one right angle. Okay. What if I wanted to make another right angle? Like that. Well, I could keep going like this. Is there any way I could get that to be a triangle? No, because as soon as I take this and I move it down to here, then it's not a right angle anymore, is it? So could I even have a triangle with two right angles in it? No. All right, so you can only have one right angle in a triangle, all right? So if you do have a right angle, obviously, what do you think we're going to call this triangle? A right triangle, okay? So a right triangle has one right angle. We mentioned another word earlier today. What was that other word? We had acute, we had right, obtuse. Very good. So what we're going to do is we're going to draw an obtuse angle. Now, could I have a triangle with more than one obtuse angle? No. Remember we said earlier, we haven't officially learned it just yet, but remember we said all the angles of a triangle have to add up to 180 degrees? So if this is more than 90, and if I had another obtuse angle, that would also be more than 90. That's two angles that are bigger than what? I got one angle that's bigger than 90, another angle that's bigger than 90. Those two angles, just those two angles would add up to be what? Bigger than 180. That's right. Is there any way I can have a triangle that is all the angles are more than 180? No, I couldn't. So there's no way I could have more than one obtuse angle. So here's my obtuse angle right here. So you can only have how many obtuse angles? One obtuse, oops, why did I make that look like a Q? Obtuse angle. So it can only have one obtuse angle. Obviously, it's pretty easy now. What kind of triangle do we call that? An obtuse triangle. So an obtuse triangle has one obtuse angle. A right triangle has one right angle. An acute triangle has what? Three, what? Three acute angles, okay? Now let me ask you something about this. What about this angle up here? I'm not going to put arc. Oh, yeah, let's put an arc. We'll put one arc here and put two arcs here. What's true about these two angles right here? Could they be a right angle? No. Could they be an obtuse angle? No. So what do they have to be? They have to be acute, okay? So does that make that an acute triangle, though? No, because an acute triangle has to have what? Not two, but what? Three acute angles. So a right triangle is going to have one right angle, and it's going to have the other ones are going to be what? Acute. What about an obtuse triangle? You have one obtuse triangle. What's this angle and what's this angle? What kind of angles do they have to be? They also have to be acute. All right? So even though you have acute angles in here, it's still an obtuse triangle. It's not an acute triangle. Remember, an acute triangle it has to have all three angles being acute, which means what? Less than 90. Everybody with me? That's not hard to figure out, is it? Now, what we're doing is we're labeling all these angles. We're describing all these angles, if you want to call it, or triangles, I should say. Let me start this again. We're describing all these triangles by their angles, right? By their angles. Okay? So we're only talking about the angles. Have I talked about the sides at all? No. I've only talked about the angles. What do you think we're going to do next? We're going to describe them by their sides. Exactly. But we're not done with this just yet. We got one more to do. Here's one that you may not have heard before. And with my little program, I can make a polygon and I can make it 3 sides, and it makes it makes all 3 angles equal to each other. So that's cool. So I don't have to like just draw it and pretend all the angles are equal. This one right here, all the angles are absolutely equal to each other. So this is equal to this is equal to this. So this is something that we've learned already. What is it? All those angles look what? Acute, right. So all these angles are acute. That's absolutely true. But since all the angles are equal to each other, now on an acute triangle, do all the acute angles have to equal each other on an acute triangle? No, they could be different angles, okay? They could be different measurements. It doesn't matter. But here's a special kind of an acute triangle. This is a special acute angle that's what's true about every single angle here. They are all equal. So when you have all angles equal to each other, then we call this, watch this, it's equi, E-Q-U-I, it's not A, it's E-Q-U-I, everybody make sure you spell this right, equiangular. This is probably not a word that you've heard until today, is my guess. But it makes sense. Where do you think that word equi, however you want to say it, pronounce it? Yeah, it's equal, right. It means all the, what, angles, see the angular right there? All the angles are equal to each other. So if you have a triangle with all 3 angles equal to each other, then we could call it what? Equiangular. You could also call it acute, but if you want to be really specific, I would call it equiangular. Everybody good with that? All right, so we've got a bunch of triangles, and we label them by their what? Angles. So now we're going to look at some other triangles that we're going to label them. We're not even going to look at their angles. We're going to look at their what? Sides. We're going to look at to see the lengths of their sides. And one of these, not the first one, but the second one, you guys have already said earlier when I asked you, what do you know about triangles? All right, we'll talk about that in a minute. But the first one is a weird one. I don't know if you've heard this word before or not, but it's called scalene. Scalene. You ever heard that? Scalene. So if it's a scalene triangle, we're not concerned about their angles. We're looking at their sides. So a scalene triangle means that no sides are equal to each other. So let me just try to draw one. So they definitely look unequal, don't they? Tell you what, let's make this, yeah, let's stretch it out like that. Now, you could have a scalene right triangle. You could have a scalene acute triangle. You could have a scalene obtuse triangle, all right? But all I'm worried about is their sides. Do you remember how I show sides are equal to each other? Remember those little tick marks? Remember we did that at the beginning of the year? So we'll say that side has 1 tick mark. This has 2 tick marks. What does that mean about these 2 sides? It means they are not equal to each other, all right? So if this had 1 and this had 1, that would mean what? What if this had 1 tick mark, this had 1 tick mark? That means they're equal to each other. But since it has 2, that means they're not equal to each other. So what would I do with this third one then, if they're not equal? Put how many? Put 3. Put 3 tick marks. So if I have a triangle and none of the sides are equal to each other, I don't care about the angles, right? None of the sides are equal to each other. We call that a what? A scalene triangle. We don't really use that very often, all right? But it's nice to know, all right? It's a scalene triangle. The second one is something that you've already mentioned. We didn't write it down, but we talked about it, and that's called an isosceles. Now let's try to spell this right. You wouldn't believe the kind of spellings I've gotten for isosceles, right? It starts off like this, I-S-O-S. Everybody write that down. Did you write it? Isos. And then the celes. You know that singer Celine Dion? How do you spell her first name? Does it start with an S? It sounds like an S. It's C, C-E, right? So it's Isos and then Celes. Her name's not Celes, her name is Celine, but it kind of starts the same way, all right, C-E-L. So it's isosceles. I don't even know where that name came from. I think I looked it up one time, but I can't remember. what it was. I don't know if it's like a Greek word or it's named after some person. I don't even know. We could probably look it up, but I just don't want to. You can look at it yourself. So here's what the definition says. It says at least two sides are equal. It says at least, which means two or what? Two or more, right? Okay. But normally, we usually save isosceles when just two of the sides are equal. Okay. But technically, it says at least two of the sides are equal. So let's, I'll tell you what, let's draw this triangle. I'm going to stretch it out a little bit like that. Oops, come on. I'll just use my arrows to move it around. There we go. All right, so check this out. What if this side was equal to this side? What kind of triangle would that be? It's isosceles, right? Because the only thing I know are the angles, or I'm sorry, is the sides. I don't know anything about the angles. That's what I was going to say. All right, the only thing I know is about those sides. I know two sides are equal to each other. All right, what if I had this? Let's make this a little bit bigger. Okay, and I said that this side, and this side were equal. Is this also an isosceles trapezoid? Trapezoid. Trapezoid was my other class. I just finished talking about trapezoids in the other class. Is a triangle. Is this a isosceles triangle? Yeah, but it's got three sides equal. I thought only two sides were equal. But really, what's the definition? At least two of the sides are equal. Does this have at least two sides equal? Yeah, absolutely. So I could consider this an isosceles triangle as well. But they also give it another name. Now, it shouldn't be that hard to figure out what this name is, at least the first part of it anyway. Do you remember the last triangle we did? When all three angles were equal to each other, what did we start off with? Equa what? Or I just gave it away. Equa, right? Got the equa part. So what do you think this is going to be? It's going to start off with what? Equa, all right? Now, it's not angular, but we're going to call it what? Lateral. That's the sides, okay? In geometry, we use the word lateral to mean the sides of something. All right, so lateral. So this would be considered an equilateral triangle because all three sides. Or I got two things I could name this, don't I? I could call this what? Equilateral, or I could call it what? Isosceles. Okay? Most of the time, if all three sides are equal, most of the time they want you to use equilateral though, okay? They usually save isosceles. I'll put that down right here. They usually save isosceles for when exactly two of the sides are equal. But you could call this isosceles if you wanted to. But again, most of the time, people would call this one isosceles, and they would call this one what? Equilateral. Good. All right. Let me talk about one thing about this isosceles triangle again. Let's do this in a different color. This side right here, the bottom, the non-equal side, do you see that? See, these two sides are equal. This is the one that's not equal. I call that the base of the isosceles triangle. The two sides that are equal to each other, we call the legs of the isosceles triangle. Okay, write that down. Because every once in a while, they'll refer to that. They'll say, what's the measure of the base of this isosceles triangle, or something like that, okay? Or the two legs of the isosceles triangle are equal to this. So you got to know what they're talking about, right? They give you a couple other things about the angles. So this angle up here, they call this the vertex angle. That's the angle that connects those two legs. Everybody see that? That's the angle that connects the two legs to each other. That's the vertex angle. And these angles down here are called the base angles. So today's a lot of vocabulary. And that's the way it is in geometry when you learn new topics. You always start off with a lot of vocabulary first, and then you learn some things about it. Okay, let's do one more. Well, at least one more. When do we get out of here? Is it 15 or 30?
30.
It's 30. Okay, I keep getting mixed up between Wednesday and regular schedule. Everybody good with that? I mean, that's just stuff you just have to look at and study, right? You don't have to be like smart to know this, or you don't have to be good at math to know this. You just have to look at the stuff. Hopefully you took good notes. I got some people not taking notes at all. One person with their head down and not taking notes. I won't say who it is, but you know who it is. All right. He's not even budging. So what we're going to do now is talk about something that, again, we talked about earlier when we first started this lesson. Stuff that some of you guys already knew, all right? But this is something you probably already know, but I'm going to show you why it's true. We give this a fancy name. This is a theorem. We call it the triangle angle sum theorem. Remember, a theorem is just a rule for something. You can prove it. Remember we had postulates and theorems a long time ago, right? You can prove a theorem, but you can't prove a postulate. A postulate, you just accept it as fact. A theorem, you can prove it. And we're kind of going to prove it right now. So basically, let's say what the theorem is, and then we're going to look at it and try to prove it, right? So it says the sum, I'll tell you what, we'll write it down. We got a few minutes here. So we're going to say the sum of the measures. So write it down. The sum of the measures of the angles, I'll just slide it right here, of the angles of any triangle. Any triangle. It doesn't matter if it's acute, obtuse, right, doesn't matter, of any triangle. I'll just put the symbol for triangle equals what? What does it mean, the sum? What does it mean if I'm going to find the sum of something? When I do what to it, though? Add them up. Add them up. That's the key. When I add up all the what? The measures of the angles of any triangle. We've already said it once before. Let's say it again. What's it going to equal? I add up all three angles. What's that going to be? 180 degrees. That's what that thing says. It's a little wordy, but that's what it means. Okay? The sum of all the angles of a triangle, that means you add them all up, that's going to equal 180 degrees. And you say, okay, well, that's nice, but why? I'll show you briefly. I'm not going to spend a lot of time on this. This part right here that I'm going to do is nothing that it's going to be on a quiz or a test. It just, I don't know. I just think it's kind of interesting to see. That's all. So if you want to write this down, you can. If you don't, it's fine too. What I'm going to do is make this a different color. I'm going to put a line right here. Remember, we just took a test on it with the alternate interior angles, same side, or consecutive angles, corresponding angles. Remember all that stuff? We're actually going to put that into practice right now, which is kind of cool to see that it doesn't just go away. Just because we finished chapter 3 does not mean that stuff goes away. In fact, my honors class is on chapter 6, and we just talked the other day about alternate interior angles and parallel lines and transversals and all that kind of stuff. So you see where it just doesn't go away. All right, let's do this. 4 and 5. I want to show you why angle 1 plus angle 2 plus angle 3 equals 180 degrees. Okay? Everybody with me on that? So let's take a look at this. This is a straight line. Look at these three angles. Look at 4, 2, and 5. 4, 2, and 5 are three angles that make a what? I just said it like 5 seconds ago. A straight line. How many degrees is a straight line? 180 degrees. Okay? You remember that, don't you? Right? From here to here. Okay? That's 180 degrees, a straight line. So check this out. Let's do this over here. Angle 4 plus angle 2 plus angle 5, what do they add up to be? 180. You see that? Why? Because they make up a line, a straight line. Everybody got that? So everybody can agree with that. We learned that very early on, that a straight line is 180 degrees. So 4 and 2 and 5 add up to 180. Well, how does that help me show that 1, 2, and 3 add up to 180? Well, I'm glad you asked. Because I'm going to show you. I'm going to show you something. I'm going to go kind of quick. I'm not going to make you think about it too much. But look at angle 1 and look at angle 4. Look, I got two parallel lines. By the way, that blue line, I should have told you before. That blue line right there, I made that parallel to this base, this bottom triangle. Okay, I should have told you that earlier. So I made that one parallel to this one. So if these two lines are parallel, what's true about 1 and 4? Give me the name. Like you had to list them. Remember I gave you a list of the first couple problems, right? The first 3 problems on the test. I asked you to list them. They're what? They're alternate interior angles. Exactly right. Everybody see it? All right? Because they're inside the two parallel lines. This is your transversal. Yep. So 1 and 4 are alternate interior angles. So what do we know about alternate interior angles? They're what to each other? They're equal to each other. So tell me something about 1 and 4. They are what? They're equal. So instead of writing angle 4, what could I replace it with? Angle 1. So I could make that an angle 1, couldn't I? Angle 2 is already inside the triangle, so I don't care about that. Let's deal with, let's look at 3 and 5. What do you think's true about 3 and 5? They're also equal to each other because they're also alternate interior angles. They're equal to each other. So instead of saying angle 5, what could I replace it with? I could replace it with angle 3. Angle 2 is already in my triangle, so guess what I just did? I just proved that the angles inside of a triangle add up to 180 degrees. I didn't just tell you that it was true. I showed you why it was true. Some of you guys don't care. It's like, Mr. Henry, look, just tell me. I just want to get the answers right on the test. That's all I care about. I get that. Okay, I understand that. But I think it goes way deeper than just getting answers right on a test. I think it's kind of cool to understand why the angles add up to 180 degrees. I'm going to show you another thing. I'm going to put my mic down. Now, on YouTube, you won't be able to see this. It's not really a magic trick, but I think it's kind of cool. So what I'm going to do is I'm going to take this piece of paper. I'll explain it so if anybody's watching on YouTube, they can listen. So I'm just going to cut a triangle. And it could be any shape at all. I'm just going to do one cut, so it's actually going to be a right triangle. All right, it's kind of a skinny right triangle. Everybody see that? Does that help? Everybody see it? So what I'm going to do, so if I took this angle, and this angle, and this angle, right, and I figured out what it was, I could take a compass, right, or not a compass, but a protractor. I could take a protractor, measure that angle, I could measure that angle, and then measure that angle. What should they all add up to be? 180 degrees. But I'm going to show you a way I can do that without actually measuring. I think this is kind of cool. So watch. I'm going to take this angle and just rip it off. Okay? So there's one angle. Do you agree? This is the second angle. I'm going to take that one, and I'm going to rip that off. Okay? Then I'm going to take this third one, and I'm going to rip that one off, if I can. There we go. Everybody see that? So now, how can I do this? If I put those together, watch. Okay. Is that 180 degrees? This angle right here? No. But watch this. Take this one and put it right here. Check it out. If I can, I don't know if I can hold onto all of them at once or not. If I had some tape. There we go. Check that out. Look, all 3 of those angles, what do they add up to be? 180 degrees. They form a straight line, don't they? You could do that with any triangle. I didn't cut that triangle out a certain way or anything like that. You can take any triangle whatsoever, rip off the corners of those 3 angles, right? Put them together. They'll always, always add up to be a straight line. I think it's kind of cool, isn't it? Yeah? You're not as impressed as my other class was. They're like, whoa, Mr. Henry, you're like magic. They were freaking out. It was last year's class. But anyway, I think that's kind of neat that all 3 of those angles add up to 180. I don't even have to measure them, do I, with a protractor or anything. I know that they make a straight line, so I know that it's 180. So anyway, I just thought that was kind of cool. Maybe you don't share my enthusiasm for it as much, but that's good enough. We got a couple more things we can hit before we finish today. So let me put the mic back on. I should figure out a way to like have the camera on the computer film me if I'm doing stuff like that. But I didn't think about it. All right, let's do another one. Let's do a right triangle. Let's go back to white. All right, let's make a right triangle. And I was tempted on that last one to talk about this next thing, but I knew it was coming up, so I thought, I'll just wait till it comes up. So there you go. So I have a right triangle. When we talked about the right triangles, what's true about this angle and this angle? This is a right triangle, so what kind of angles are these two right here? They're acute. Anytime you have a right triangle, the other two angles, right? The other two angles are going to be acute every single time. Everybody understand that? Okay. But there's also something interesting about those two angles. Call this ABC. All right. I want you to tell me something about angle B and something about angle C, like mathematically. This has to do with the 180 thing, right? What are you going to say? Okay, they're both acute. We already established that. Okay, so they're both less than 90 degrees. I want to be more specific than that. They add up to what? 90 degrees. How'd you get that? Okay, this one's 90 degrees, right? So what do they all add up to be? 180. So watch. The angle, well, I'm not going to put angle A. I'll just put 90 degrees. Okay, so the 90 degrees plus the angle B. Let's scoot this over. I don't know why it's so far away. There we go. Plus the angle C equals what? 180. But on a right triangle, I'm always going to have a 90-degree angle, right? So what can I always do? I could always do what to it? Subtract a 90 from it. Everybody see that? Just did a little algebra. That cancels. So what does angle B plus angle C always add up to be? 90 degrees. Okay? So it doesn't matter. So what if this was 30? Do one quick math problem to get to angle C. Should have done the other way around. That looks more like 30, but that's okay. What could I do? Do I have to go 180 minus 90 minus 30? No. I know it's a right triangle, so what can I do? One math step. Boom, I'm done. I got angle C. Why is it 60? What math did you do in your head? Yeah, but did you have to do 180 though? Did you have to go 180 minus 90? That's right. See, these two add up to 90. So if I know angle B is 30, how do I find angle C? Just subtract 30 from 90, right? I don't even have to think about this being 180. All right, that just saves you a little bit of work, right? Instead of doing the whole 180 thing all the time, all right? Because a right triangle, it's always going to have a right angle. So I know that these two always add up to 90 degrees, all right? So if this was 30, this would be what? 60. I didn't draw them very accurately. This should have been the 30. That should have been the 60, but that's okay. The math still works. So here's what they tell you. This is a theorem. They actually call it a corollary. A corollary just means like a little mini theorem. Okay, it's a sub-theorem. It has to do with that 180 degrees. Would you agree that this thing has to do with the 180? Because I added all these up, set them equal to 180. So it has to do with that last theorem, but it's its own little baby theorem, I guess. We call those corollaries. And it says that the acute angles, I'll write it down, it's not too long. The acute angles of a, not any triangle, but of specifically a what? A right triangle, okay? The acute angles, which means this one and this one. The acute angles of a right triangle are, now I'm going to give you a big geometry word. We already know the geometry word when things add up to 180. What's the geometry word when things add up to 180? Supplementary. But we have another word when things add up to 90, okay? And it's complementary, all right? I don't know if I've mentioned that in here before, but that's what it is. Complementary, supplementary. Okay, supplementary means they add up to 180. What does it mean when they're complementary? They add up to what? 90. Okay, they add up to be 90 degrees. Okay? Let's do one more and we'll quit, okay? Promise. Let's make one of these again. Now, I'll tell you what, I got to tell you this, though. This is an equilateral, let's say this. It's equiangular. We haven't talked about that yet. We'll get to that in a second. What I was thinking is, I'll tell you right now, since I'm thinking about it. Remember we did equilateral? Look at that equilateral triangle. Look at that equiangular triangle. It kind of looks like what? Yeah, it kind of looks like they're the same. I mean, one might be a little bit bigger than the other. But look, all the angles of this angle, or of this triangle, look like the angles of this triangle. So we have a thing. I don't know if we've gotten to it, but I'm going to tell you right now, since I'm thinking about it, that if it's equiangular, it's also, what do you think? Equilateral. That's right. So every time you have an equiangular triangle, all the angles are equal. That automatically means that what? Then all the sides are equal to each other. Okay? So that's kind of cool. So let's go back to this. All right, so I could say all the sides are equal, couldn't I? All right, because if it's equiangular, it's also equilateral. But what I want to do, just with this information, I want you to tell me how many degrees is each of these angles. Give me an actual number, and it's not a guess. You can find it exactly. Let's do this. Let's say we don't know what that angle is, do we? Let's just call it x. Is that all right? We'll call that x. So what am I going to call this one down here? Am I going to call it y? Why would I call it x again? Because they're the same. Exactly right. Because they're exactly the same. All right? So if that's x, and this is exactly the same measurement, right? The same angle as this one, I'll call that x. What am I going to call this one? I'll call that x as well. So what do we know about all three of these angles? What do? They add up to be what? 180. So let's add them up. X plus x plus x equals what? 180 degrees. Now, if I can solve for x, then I can find what each of these angles are. Okay? So let's do it. Let's add like terms. X plus x plus x. What's that? 3x. Do you see it yet? Now what do? Divide by 3. X is 60. 60 degrees. So, how much is this angle right there? It's 60 degrees. How much is this one? That's 60. How much is this one? It's 60. All equiangular triangles. Only when they're equiangular. Okay, if they were different measurements, obviously they can't be all 60, right? So if it's equiangular, it's 60 degrees. Or if it's equilateral. Because if it's equilateral, then I know it's also equal what? Angular. All right? You with me on that? So all three of these sides, if they are equal to each other, then that must mean all three angles are equal to each other. It doesn't matter how big, it doesn't matter how small your triangle is. Anytime you have an equiangular triangle, those angles are going to be 60 degrees each. Do they all add up to 180? Sure. 60 and 60 is 120, plus another 60 is 180. They do, and they're all the same. So that's kind of interesting, don't you think? Right? So every equiangular triangle, the angles are 60 degrees. All right. So I want you to give it a shot. I don't know if you can do all of them or not, but do as many as you can. I'm not sure how far I needed to get to be able to do these, but there might be some things that you can't do in here, but do as many as you can, okay? We're going to do 1 through 16. It's on your lesson plan thing, and we're right on track for this week, so everything's right on. So it's page 151, 152. 151, 152, and this is section 4.1. And we're going to call it 4.1a because we've got a little bit more to do, and then we got another homework assignment after the 1 to 16. So do as much as you can with 1 to 16. Everybody good? All right. Thanks for listening. You guys were great today. I appreciate it.